Hi, this is Jim, and I'm just giving you a very brief intro right now to what's coming up. I'm going to be going through Unit 2 of the course Ebook. This covers the origins of computers, a little bit about computer history, stressing mostly what happened later on with computer history to lead to the kinds of devices that you're familiar with today. And I'll also have a little bit of information at the very end of this about very modern computers, that is, the kind of computers like the iPad 2. I do happen to have one. I invested in one so that I could do very complete research for this kind of a course and keep it up to date. So I'll show you a little bit about that that might be informative to you as we wrap up Unit 2, the history of computers, and leading up to contemporary computing in Unit 3. You have 2 weeks to do this unit, but Unit 1 ends October the 2nd, and a week later Unit 2 ends. So we're kind of overlapped here because I gave you a little more time on Unit 1, but Unit 2, there's no extension. It really does end after the 4th week of the term, which will be October the 9th is when Unit 2 is scheduled to end, and it will end then. Units 3 and 4, you have 3 weeks each on, because they really start digging into doing some hands-on programming work. Well, not programming work, but some hands-on fun work with computers, sound editing, picture editing, video editing, all sorts of interesting stuff that I think you're really going to want to put a lot of attention to, so you don't want to have Unit 2 hanging around once Unit 3 starts. Let's dig in. I'm going to tune in to the course website at q123.us/200. Of course, you've done this many times, but I just wanted to show you I changed things just a little bit. I'm going to be showing you things about Unit 2 in the course ebook. If I go to download the course ebook, you're going to get to a page that looks a little bit different. You've already done this. You don't need to download it the second time. But if you haven't yet done it, I just wanted you to see what's coming at you. Download the course ebook. Here's the click here. You'll go to a page that looks like this, and the only purpose of this is to give you some instructions and a little bit of preview about what's coming at you in the ebook. You want to go here and read these instructions, right mouse click this, and save the link as. Now I'm using the Chrome browser, and this is going to give me the ability to say where I want to put this. So if I clicked save, it would download 20 megabytes more or less. Well, I'm not going to do that because I've already downloaded this. I just wanted to show you how to get this thing. What I'm going to do right now is go into the ebook, opening it up, and I'm going to first of all show you, if you haven't already caught on to this, the way to view this most effectively. You don't want to view it at such a large size and do all of this awkward scrolling around. What you really want to do is to say View and Full Screen Mode. That way you can use the right arrow key to go through this page by page. By the way, I should have corrected this typo here. That's not really the email address you send your material to. Now it's gph205autumn@gmail.com. Well, there's another way to go through here I find even better. I just click the Escape key. If I go to View, Page Display, Two-Page View, the first page will look as it is a cover, and then you'll see the pages two up. This grading sheet I've revised a bit, so you have a different one that comes at you from the course website. Aside from that, we can take a look at what's going on here with the table of contents. I'm going to be looking at the computer evolution, that's Unit 2, and I'm going to go through several things there just to show you what's coming down the pike and give you kind of an overview, the same way that I would do if I were lecturing about this in class. So let's go find the beginning of Unit 2. What we're talking about here is basically a bit of history, something to show you where the first computers were manufactured and what they looked like. They were experimental machines in the Second World War. That's about 70 years ago. The technology at the time meant that they had to use vacuum tubes as circuit elements. Today we use transistors and integrated circuits, and the circuitry is very small. Back then it was very large. It was crude, but it actually was possible to demonstrate the idea of storing information in bits, as you've already learned in Unit 1, and controlling circuitry with those bits, sometimes interpreting them as instructions and sometimes interpreting them as representing information, primarily numbers. In fact, these are called computers because the initial thought was they would be used to perform computations. And now, of course, it's been generalized a great deal to handle information of any type. So you see here the earliest of these machines, which were experimental. They were not manufactured for sale. They were constructed by universities to learn about how computers might be made. About 20 years later, in the 60s, IBM was one of the largest manufacturers. There were other manufacturers and mainframes, very large machines that filled rooms. They were competent machines, but they generated a lot of heat. Rooms like this had a hollow floor where a lot of cables ran to hook up all this equipment. These were expensive machines. Initially, it was thought only the largest government organizations and industries would be able to afford them. No one at that time could envision how circuitry would be miniaturized, and computing horsepower like this and even more would be found in very tiny devices, even as small as cell phones these days. Let's take a look at evolving architectures. Here's something very important for you to understand. Very, very important for you to understand. The personality of these machines as they were originally developed was what we call batch-oriented. That is, we would pile up transactions, perhaps on punched cards, paper cards. We would have existing master files of information. These would be drawn into a process that produced reports and an updated master file. So these transactions were applied to the master file, creating a new master file. And update runs like this might be run perhaps every day. So transactions pile up, documenting the sale of things or various other kinds of business dealings, and the master file would be updated once a day. This file could be used to produce reports at the time of update, perhaps transactions that were miskeyed, that is misentered and didn't make it, had to be cleaned up, cycled around the next time, or reports from the information here, totals and the various kinds of reports that might be built up to show subtotals and totals rolling up into it. That's called control break reporting, and it was very common and still is for accounting purposes. These kinds of machines fit very well into accounting departments. However, in the late 1960s, a different form of processing came to the fore. This required a whole different look at the way computers would work. The very first application of this type was airline reservation systems. Airline reservation systems need real-time access. You may have people in many different parts of the country selling tickets on the same airplane at the same time. Well, how are you going to avoid overbooking? You hear about it now, and it's kind of intentional to do it. But back then, the idea was we just wanted to make sure we didn't sell the same thing twice. And people wanted information right now, knowing whether they could get on a certain flight at a certain day and have a seat. So these kinds of things forced people to use computers that were designed for this kind of processing in a different way. And that different way is called online processing. This is called batch. This is called online. To make a machine of this variety that was designed to do batch processing into something that could handle this, engineers went through some real hoops to do that, and it was possible to do it. It was done with something called a teleprocessing monitor, which was a program running on the system all the time that terminals could talk to. It was very efficient but very complicated to do this kind of processing. It did make it possible for a mainframe that by today's standards was not very powerful to handle thousands and thousands of transactions an hour, even a second. But because the programming is complex, those systems took a long time to build, and they weren't very easy to change. So maintainability was sacrificed in order to gain the efficiency, but it was certainly possible to do that. And even into the 90s, and at the present time, some very high volume applications still use that type of processing on large mainframes. As the circuitry to make computers was miniaturized, first transistors in the 1950s, replacing vacuum tubes, and then transistors grown together as integrated circuits. The integrated means the transistors are all put together when they're grown on a silicon wafer. That means that all the labor to interconnect those components is done way ahead of time when the circuit is designed. They're the kind of gates that we talked about in Unit 1, miniaturized, several layers of silicon and insulators being grown on a wafer, hundreds of them perhaps on one wafer, several inches in diameter, and then each cut up and put into a package. So instead of taking individual transistors and wiring them up on boards and making computer circuits in that way, the computer circuits were designed ahead of time to be grown already put together. This miniaturization meant that what formerly in the 60s would have taken a room full of equipment might be put together in a small cabinet. At least a computer that could support a few terminals, inherently online in nature. These small machines were not designed to be batch machines. They were designed to talk directly to terminals in real-time processing or time-sharing processing, something where people expected to be able to access the machine directly. So you might think about that as a different way of thinking about a computer. With the mainframe, people stood at a distance from it. It was really designed in the IBM environment to be fed with paper punch cards, a batch machine that had to be adapted to online purposes. In this environment of mini computers, which took prominence in the 70s, 80s, and 90s in some organizations, it was coupled with distributed processing. That is, the equipment was distributed, and some of the functionality was put out there in various departments. Now, what happened actually was some contention arose. The central data processing organization that had the mainframe felt that these people were competing for some of the kind of work that should have been done in one location. So the organizational phenomenon that occurred is either centralization of this information technology function or distribution of it to different places in the organization. Then comes along the PC in the 1970s and refined for business use in the next decade, and by the 90s a real factor in the business environment. First of all, what happened with them was they began to emulate these fixed terminals. So someone might have a PC out here that they were using for word processing, and it could also emulate a terminal, so they wouldn't have to have one of these dedicated devices to talk to the mainframe. They could go through a local area network where these machines could talk to one another and also communicate with the mainframe. On the heels of that development came along the internet in the 90s, and a connection through some type of a router to the internet made these devices even more flexible. So here we have essentially grown-up powerful personal computers in the form of servers interacting with the mainframe, interacting with the internet, and interacting with all these terminals. So the terminals, which were really PCs, could gain the benefit of internet access, mainframe access, or do some local processing themselves. These were called dumb terminals. These were smart devices that could act like terminals. This progression continued until finally the servers became powerful enough and ran software such as industrial-grade databases that some people considered and actually did pull off the feat of replacing the mainframe with large farms of servers. Still, a centralized organization would be programming these, and the smart devices out here in a local area network would access applications, that is, software programs being run on this replacement for the mainframe, and a connection to the internet where communication to the outside world was possible. This is very common these days, and in fact is pretty much the mode of processing in many organizations such as DePaul. DePaul used to have a mainframe. It replaced it about a decade ago with this kind of configuration. So the software is completely different. There is one kind of a difference here, though, that is significant. The old environment of the mainframe could process thousands of transactions an hour, certainly hundreds per second. This environment is more inherently online, that is, it's more inherently conversational, but it's not as fast and not as efficient as doing that. So, for example, our registration system, people used to all register at the same time because the system could handle it, a mainframe tuned up for that. Now you're staged in registrations. You have a slot, and it's done so that various people register at different times so the whole load doesn't hit the system at one time. We gain more flexibility this way, but there are some constraints in terms of the resources available. What about cloud computing? What this refers to is actually the idea that out here on the internet, there could be data centers, there could be devices to store information. We've got big guys out there on the internet like Microsoft, Amazon, places that have big data centers like Google, thousands and thousands of servers, and they are in the business of adding capacity to that all the time, disk storage and computing capacity. Well, how about instead of having your own equipment here, like some big server to support your applications. Suppose you just sort of outsource that by renting the computing time and the storage space from out here in the internet, which is pictured as this cloud. You really don't know where it is. It's just out there with high-speed internet connecting you to places that can provide the horsepower. This is an interesting idea. Some places are using it. For example, when the Olympics occurred in China, it presented a huge load all of a sudden for processing, and cloud computing was used to do that because lots of computers all over could handle the kind of inquiries that were coming in about the Olympics. After the Olympics, well, that same kind of horsepower didn't have to be dedicated to that application. It would have been silly to build a big data center to beef up to that and then dismantle it. So instead, these kind of connections through the internet were used. This is a big picture of where computing came from and where it's at the present time. We all know that these devices have kind of morphed into mobile devices now, and Wi-Fi, hooking things up without wires. So basically, we've seen the pendulum go from centralized computers out to distributed, back to centralized with this form of servers, and now being decentralized again massively with mobile devices and very smart cell phones that can do a lot of computation on their own.